Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing illustrative math, grade 8, unit 8, lesson 10, practice problems. Okay, our first problem here says a man is trying to zombie-proof his house. He wants to cut a length of wood that will brace a door against a wall. The wall is 4 feet away from the door, and he wants the brace to rest 2 feet up the door. About how long should he cut the brace? So this is a nice right triangle with legs of 2 feet and 4 feet, and we want to find out the length of the brace. So Pythagorean theorem, a squared plus b squared equals c squared. 2 squared plus 4 squared equals c squared. 2 squared is 4. 4 squared is 16, is equal to c squared. 4 plus 16 is 20. To isolate the c, take the square root of each side. So the square root of 20 is equal to c. Okay, next question here. At a restaurant, a trash can's opening is rectangular and measures 7 inches by 9 inches. The restaurant serves food on trays that measure 12 inches by 16 inches. Jada says it's impossible for the tray to accidentally fall through the trash can opening because the shortest side of the tray is longer than either edge of the opening. So, let's think about what these would look like. If this is our trash can, it is 7 inches by 9 inches, and our trays are 12 by 16. So this looks larger than the opening for the trash can, so it seems like it probably won't fit. However, if you were to put in the tray diagonally, I wonder if it would fit this way, because if this distance is greater than 12 inches, the tray can still fall into the trash can diagonally. So let's check out what that distance is. That is the hypotenuse. 7 squared plus 9 squared equals c squared. 7 squared is 49. 9 squared is 81, is equal to c squared. 49 plus 81 is 130. So now to know what c is, take the square root of each side. So the square root of 130 is equal to c. Exactly. But we need that to be less than 12 inches. Is this less than 12 inches? Well, 12 squared is 144, so yes, this is less than 12 inches. Let's find out exactly what it is. It's 11.4 inches. So diagonally, that's 11.4 inches. This tray is not going to fit in there. Okay, our next question, select all the sets that are 3 sides of right triangles. This would have been easier if they were all on the same page, but okay. To know if these sides make a right triangle, you just have to put them into the Pythagorean theorem and see if it holds up. So does 8 squared plus 7 squared equal 15 squared. 8 squared is 64. 7 squared is 49. 64 plus 49 is 113. 15 squared is 225. Does 113 equal 225? No, it does not. Okay, for the next one, we have 410 in the square root of 84. So first off, we have to know which one of these sides is longest so that it's the hypotenuse. The square root of 100 is 10, so the square root of 84 is less than that. So the 10 must be our hypotenuse. So does 4 squared plus the square root of 84 squared equal 10 squared? 4 squared is 16. Square root of 84 squared is 84. 10 squared is 100. 16 plus 84 is 100. 100 equals 100. That works. B is a right triangle. Okay, now let's check C. Square root of 8, 11, and the square root of 129. Which one of those is our hypotenuse? Well, the square root of 121 is 11. So this is larger than that. So this is our longest side. So we have square root of 8 squared plus 11 squared equals the square root of 129 squared. 8 squared is 64. Nope. Whoopsie. The square root of 8 squared is just 8. 11 squared is 121. Square root of 129 squared is 129. 121 plus 8 is 129. So this one works. Now our last one here, square root of 1, 2, and the square root of 3. 2 squared is 4. So the square root of 3 is less than 2. So 2 is our longest side. So square root of 1 squared plus the square root of 3 squared equals 2 squared. Square root of 1 squared is 1. Square root of 3 squared is 3. 2 squared is 4. 1 plus 3 equals 4. 4 equals 4. That one works. So this one is a right triangle. So B, C, and D were right triangles and A was not. Okay, next question here. For each pair of numbers, which of the two numbers is larger? So what is larger? 12 times 10 to the 9 or 4 times 10 to the 9? 12 is larger than 4 since our scientific notation they were both 10 to the power of 9, which is the same. How many times larger? Well, now we have to divide 12 times 10 to the 9 over 4 times 10 to the 9. 10 to the 9 over 10 to the 9, when we're dividing, we subtract exponents. 9 subtract 9 is 0, which is just 1, so those go away. Or you could think of it as anything divided by itself is 1. Those cancel, so it's 12 over 4. What's 12 divided by 4? That's 3. So 12 times 10 to the power of 9 is larger, and it is 3 times larger. Our next one here is 1.5 times 10 to the 12, and 3 times 10 to the power of 12. They are both times 10 to the power of 12. Which one is larger? Well, 3 is larger than 1.5. So this number is larger. How many times larger? We can divide again. 3 times 10 to the 12 over 1.5 times 10 to the 12. 10 to the 12 cancels out again. We have 3 over 1.5. 3 divided by 1.5 is 2. So this one is larger, and it is 2 times larger. Last one of these, 20 times 10 to the power of 4 and 6 times 10 to the power of 5. So this one, the powers are not equivalent. However, this number is not in proper scientific notation with the 1 digit before the decimal point. So we should turn this into 2 times 10 to the power of, we had to move the decimal point 1 spot. This is greater than 1, so we have to increase the power from 4 to 5. So now it's a little easier to tell which number is larger. 2 times 10 to the 5 or 6 times 10 to the 5. The power of 10 is equivalent, so we can just look at the numbers. Which one's larger, 6 or 2? This number is larger. How many times larger? Well, as we can see, nice little pattern here, the power of 10 is the same with both of them, so those will just cancel each other out. So 6 divided by 2, which is 3. 6 times 10 to the 5 is larger, and it is 3 times larger. Okay, a line contains the point 3, 5. If the line has a negative slope, which of these points could also be on the line? 2, 0, 4, 7, 5, 4, 6, 5. So let's think about what this is going to look like. If we have the point 1, 2, 3, 1, 2, 3, 4, 5. And if the line has a negative slope, it has to look something like that. It could be steeper, it could be, that wasn't a very good line, it could be shallower. So which of these points could be on that line? 2, 0, 2, 0. Well, that point could not be. If this line has a negative slope, it's going down, and connecting those 2 points would have a positive slope. So it is not that one. 4, 7. 4, 7 would be up here. That's also not going to work, because connecting those 2 points would have a positive slope. 5, 4. 1, 2, 3, 4, 5. One, 2, 3, 4. 5, 4. That looks possible. That's practically on one of the lines that I had drawn. And 6, 5. 6, 5. Well, 6, 5 is a y value of 5, and 3, 5 is a y value of 5. So those lines, those 2 points would create a horizontal line. A horizontal line has a slope of 0, which is not negative. So our answer is C. Noah and Han are preparing for a jump rope contest. Noah can jump 40 times in 0.5 minutes, 40 times in half a minute. Han can jump y times in x minutes, where y equals 78x. If they both jump for 2 minutes, who jumps more? So Noah, 40 times in half a minute, but they are jumping for 2 minutes. So if they're jumping for 2 minutes, 40 times in half a minute would mean 80 times in 1 minute. If he jumps 80 times in 1 minute, he would jump 160 times in 2 minutes. Han jumps y equals 78x times. Well, x is our time in minutes, so that would be y equals 78 times 2 minutes. 78 times 2 is 156. So who jumps more times? Noah does. We could also tell that pretty quickly once we figured out that Noah jumped 80 times in 1 minute. That gives us a unit rate we could compare. His unit rate is 80. Han's unit rate is 78. However many minutes they jump, Noah will jump more times because his unit rate is faster. This has been another episode of Mr. Boskin Does Some Math. Thank you for tuning in. See you next time.